Now that we're getting pretty familiar with sums, the idea of a summation, that we're summing over some sequence, indices, etc., let's look at some specific properties of sums. So suppose that we have two sums, a1 plus a2 plus a3 plus all the way up to plus an, and b1 plus b2 plus b3 plus all the way up to bn. Before we do anything, let's write these in terms of sigma. So since we see all of these sums, that should make us think, okay, we need a sigma. Looks like we're starting at the index k equals n, and we're going all the way up to the nth term of the sequence a sub k. Similarly, for our b's, we've got a sigma to indicate that we're summing, starting at k equals 1, ending at n of the sequence b sub k. So I want to see what happens when we add these two summations. So we'll use the written out, the expanded form of each of these summations to make it a little bit easier to see what's going on. So we'll have a1 plus a2 plus, and to save myself a little bit of writing, we're going to go right to plus an plus the sum b1 plus b2 all the way up to bn. Now we could rearrange these. I think this will make it a little bit easier to see what's going on. Let's group all of the term numbers with index 1 together, and all the term numbers with index 2 together, and all the terms with index n together. So we will have a1 and b1. We'll have a2 and b2. We'll have all the way up to an and bn. And just for being super clear about what's going on, I love using substitution as a tool for highlighting what's happening. So let's say Cn equals an plus bn. Now, that means that C1 will equal A1 plus B1, and C2 will equal A2 plus B2, all the way up to Cn equaling An plus Bn. So that means that we'll have the summation C1 plus C2 all the way up to Cn. And we can concisely write this. We know how to do that. That's the sum from k equals 1 to n of c sub k. Well, we just substituted something in, right? This is going to equal the sum from k equals 1 to n of a sub k plus b sub k. So this is just saying that the addition of two sums is the sum of the addition of sequences. So this is really convenient for us. This helps simplify a lot of solutions. Let's look at one more thing before we move on to formal definitions. Suppose we have a sum that looks like this: CA1 plus CA2 plus ... plus CAN. Well, since each of these terms has a common c, this constant c, which is a member of the reals, we can just factor out a c, and we'll have a1 plus a2 plus up to an. Well, we already know a nice name for a1, the sum a1 up to an. We can just call that sigma, starting at k equals 1 and going to n of a sub k. But we also have this c here, so we just have a c. So if we have a sum of terms of the sequence ak, each being multiplied by some constant in the real c, we can just factor out that c out of the sum. So this statement is equivalent to the sum from k equals 1 to n of c ak. So formally, these properties are summarized here. Let a1, a2, a3, and so on, and b1, b2, b3, and so on be sequences. Then for any n in the positive integers and c in the reals, the following hold. The sum of two sequences is the sum of each of those sequences. So the sum from k equals 1 to n of ak plus bk equals the sum from k equals 1 to n of ak plus the sum from k equals 1 to n of bk. Similarly for subtraction, right? Subtraction is just the opposite of addition, so it shouldn't be that difficult to prove to yourself that this is true. And then the third property is that for any constant